Heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
And hello, everyone. Welcome to the second lesson in our virtual classroom series. My name is Francis Terrazowitz. It's a pleasure to meet everyone. I am an education specialist as well as weather observer up here on the summit of Mount Washington. And if you don't know already, Mount Washington Observatory, we're a private nonprofit organization, member supported, of course, and we have the mission of understanding the systems that create Earth's weather and climate. And so a big part of that is weather observations. So our lesson topic today, of course, is the introduction to weather observations. Up here on the summit, we're all weather observers. We're noticing, we're characterizing, and quantifying weather observations each and every day, every hour of every day, actually. And so to track these variables, we use instruments, and we need instruments that are accurate. We need instruments that are precise, reliable, ones that can survive the extreme conditions up here on the summit that we frequently encounter. And finally, instruments that we can repair, because eventually they will break. So we need to be able to repair this as observers up here on the summit. So why are we taking these measurements? Well, we're trying to characterize the state of the atmosphere at any given time. We're trying to paint a picture with the data that we collect. So we collect these observations every hour. And so we're collecting observations of temperature, pressure, the motion of the air, as you know, is wind, as well as water, both in the gas form, liquid form, and as it does fall as precipitation. We're going to get into each of these variables now, starting with temperature. And temperature is simply describing the kinetic energy, or the energy of the motion of air molecules. So to track these motions, we use things called thermometers, which you may be quite familiar with already. Within these thermometers, we have liquids that are sensitive to changes in that molecular motion as those molecules move or slow down. And so typically with warmer air, we expect those molecules to speed up, and with cooler air, those molecules are going to slow down, stay nice and bunched up together. So temperature is closely related to pressure as a result, and changes in pressure are the result of changes in temperature. And usually air will move from high to low pressure, and that's what gives us our wind action here on the summit and around the planet. Barometers are a useful tool to actually record pressure. And I just want to bring your attention here now to this graphic that I created. We're showing two different types of pressure that we experience. High pressure is associated with these air molecules, those little gray circles you see there, being bunched up together near the surface, and high pressure, usually the air is sinking, so it's really bunching those up. Temperatures are also a little bit cooler with that, so that the air is more dense. Compared to low pressure now, low pressure, the air is rising, the air may be a bit warmer, and those air particles, molecules, if you will, are spaced out more in a larger way. So as I said, that pressure relates to wind. That wind is flowing from a high to low pressure along the pressure gradient force, we call it. And so how do we measure wind? Well, we have a bunch of different types of instruments here on the summit. I want to bring your attention here to the propeller. And so we put these on the end of what's called an anemometer. And the faster the wind is, the faster this propeller will spin. We also do have another unique instrument up here on the summit. So sometimes, especially during the wintertime, our anemometer will freeze over and potentially break. So what we use instead to measure wind, I'll come right up to the camera, it's called a pitot tube. And so wind will go into the front of this, and the difference in the air pressure around the tube compared to the force of the air going in the tube gives us a sense of our wind speeds. And so we can heat this up, and so we can keep those observations flowing even during the most severe winter weather we experience here on the summit. So we're also measuring water, and we're measuring water in different states. The first of which is the water that's just in the air around us, the water vapor. And so I'm going to come right back up to the camera. So to do that, we use what's called a sling psychrometer. And that consists of two types of thermometers. The bottom one is just your regular old thermometer. We call that the dry bulb thermometer. The top one is our wet bulb thermometer. And on the tip of that, you may see this little sock here. and this sock is useful for dipping into water. And so after we dip it in the water, we give it a good old spin in the atmosphere. And so the more water that's evaporating on this top thermometer means that the thermometer is cooling down. And so the more this cools, we can assume the drier the air is, the more water that evaporated from the sock into the surrounding air. And so we track the difference between these two temperatures, and that's how we get a sense of our relative humidity or how much moisture is actually available in the air right now. Water is also condensing above our heads in the form of clouds. And so as observers, we're paying attention to cloud layers, cloud heights, as well as types of clouds and how much of the sky they're actually covering. So behind me here, you can see a really beautiful example of lenticular clouds. And these are a sign of more severe weather on the summit. So wind flowing rapidly up and over the summits and causing a sort of flat sheet of clouds. And so pilots will see our observations and know to steer clear of the summits on the day that these types of clouds are joining us here on the summit. Water is also falling out of these clouds in the form of precipitation, things like rain, sleet, snow, even hail sometimes. And so to collect that, we use this gigantic rain can here. And every 6 hours or so, we're tracking how much rainfall or liquid precipitation has fallen on the summit here. It gives us a sense of how much water is going to be available for the valleys and lower elevations. So weather observations, putting it all together, we're painting the picture of the atmosphere through a point in time. And so we're also tracking the time at which these observations are changing. So that's why we do it every hour. We can see how the weather is changing as we go forward. And again, this paints a picture for atmospheric motions, the movement of storms, the movement of things like hurricanes and severe weather as well. It helps us to understand weather patterns as meteorologists so we can inform the public about potential severe weather. And so observations are a useful tool, just sort of putting it all together again. We put the observations into our computer models, and those computer models help us to forecast the future weather. So the more accurate our observations are, of course, the better those computer models are going to be. Our forecasts also up here on the summit, our higher summits forecast gets used mainly by people who are recreating up here, people who are climbing the mountain, skiing the mountain. And so our observations are really, really important to those operations. Weather affects all of our lives in some capacity. And so here on the summit, we want to answer what can we learn about observing changes in the weather, and what can we also learn by paying attention to those subtle changes in our observations. And something you can do at home is just watch the weather, watch how the clouds change throughout the day. Look to see if there's any changes in precipitation, wind speed, temperature, things like that. And you can be an observer as well. Speaking of being an observer, I'd like to now do some observing of our own. And so you can do this anytime at mountwashington.org. We have our webcams and weather data hosted 24/7. So speaking of webcams, I'd like to take a quick look outside on our deck. We can see here a beautiful, beautiful day. Just a few high clouds indicating fair weather. Nothing really too exciting going on, but again, a beautiful day. You can see for about 130 miles today. We'll take a look at the summit from Wildcat. Wow, the camera changed a little bit, but you can see the summit there totally in the clear, and just some of those thin, wispy clouds above us. I'm going to step off camera for a moment, and I'm going to pull up our higher summits forecast and observations page. You can find this again at mountwashington.org. And I'm going to pull up now the website. You can see here the current observations on the summit, including the wind speed. Our wind speed that's here in the circular diagram. It kind of looks like a speed dial on a car. We can see our temperatures, how they're changing as we go up the autoroad. I'm going to zoom in a little bit for you all here. And so we get a good sense of how temperature is changing with height. So of course, at the summit here, we're a little cooler than what we see at ground level. I mentioned visibility in clouds. And so today the visibility bar is nice and full. It means we're at 130 miles of visibility up here on the summit. And finally, some other variables that we've observed. Again, our wind speed, wind direction is very important as well. And that atmospheric pressure that I mentioned a little bit earlier in the presentation. And so I would like to thank you all for joining me for this virtual lesson. And of course, you can send along questions that you have. We also have live Q&A sessions with myself or my fellow observer, Alex. And again, thank you for clicking on today's lesson. You can always, of course, visit mountwashington.org for the latest in mountain meteorology. And we look forward to seeing you with the next lesson. Have a great day.